Welcome back, everybody, or for those of you who are just able to join us this evening, welcome to the opening day of the inaugural CMU K&L Gates Conference on Ethics and AI. I'm David Danks, one of the co-organizers, along with Ela Norbash, of the conference today and tomorrow. That is really bringing together a group of interdisciplinary and multidisciplinary thought leaders to help advance the conversation around the areas of ethics and AI, the ways in which technologies, especially computational technologies, are able to help us support and advance human values. And one really important part of this conversation is the distinguished keynote lecture that we have this evening, which is really, I think, going to be a highlight of the conference. And to introduce the speaker, it is my honor to bring to the podium Mr. Mike Caccese, who is the chairman of the management committee of the law firm K&L Gates, as well as a world leader in investment management and regulatory compliance. Mike?
Thank you very much, and it's a pleasure being here. And I have to tell you, it is an honor to introduce Dr. Eric Horvitz. When you think of the purpose of this inaugural lecture, to talk about current trends, future trends, challenges, and opportunities in ethics and artificial intelligence, you couldn't think of a better person to do it than Eric. Eric has been active in addressing many of these issues for over 30 years. He's currently the director of Microsoft Research Labs and at Microsoft as a technical fellow and in Redmond, Washington. As I mentioned, his whole career has focused on that. He has this unique skill that in this area where it can be so technical and very difficult in order to take all the various issues that are being faced in order to describe it in, well, I would say in layman's terms. He has this excellent skill to take these concepts and let the average person understand the opportunities, the challenges, the benefits. He has worked on safety issues in the space shuttle, but also at the same time, he has done fantastic work in AE dealing with email systems and scheduling systems. So every day, our everyday lives have been changed by some of the work he has done. You know, Eric, he's really a double doctor. Not only does he have a PhD, he also has an MD. So a lot of his work has been done focusing in the medical field. One of his challenges has been, and worry always has been, is as doctors under stressful conditions in emergency rooms and other situations get a lot of data. How do they analyze that and help the patient understand that? That's some of the efforts that Eric has focused on. He did his dissertation 25 years ago talking about these issues, and his first publication was on Pathfinder, which was a tool to help internships in the diagnostic area, in order to simplify information they receive to help them make better decisions. Recently he's been a leader to examine the many difficult ethical, social, and psychological questions raised by advancement in AI. In 2009, while he was the president of the Association of Advancement of Artificial Intelligence, commonly referred to as AAAI. He also chaired the groundbreaking Assimilo AI study, which brought together a blue ribbon group, and many of those people are in this room, to identify and examine the potential human and social impacts of AI research and development. The study has helped set the agenda for many of the topics at this session here, the past day and tomorrow. He co-founded the 100-year study on AI to anticipate the diverse effects of artificial intelligence on every aspect of our lives in the coming century. Throughout his writing, Eric is not a doomsayer, he's not a futurist, he's a very practical person, taking all the different aspects of this burgeoning area and using it to reshape our lives and also use the challenges and opportunities to help society in the AI area. Eric has received numerous rewards. He's a fellow of the National Academy of Engineering, the American Academy of Arts and Sciences, the American College of Medical Informatics, the AAAI, as I mentioned, and the Association for Computing Machinery, or commonly referred to as ACM. He has advised government agencies, foundations, major research institutions, and has testified in front of the U.S. Congress. In 2015, he received both the AAAI Feigenbaum Prize for Outstanding Artificial Intelligence Research in Real-World Domains, and also the AICM AAAI Newell Award, named for CMU's own Alan Newell, for its contribution to artificial intelligence and human-computer integration, which integrated both computing and decision sciences. He has developed some of the core methods and systems to advance our understanding of machine intelligence and works to harmonize these advances to improve our everyday lives. As technology is spreading in all aspects of our lives, communities, and societies, Eric has always been a leader in this area. Again, he's very practical. He balances the pluses and the minuses, and he turns them into areas that will improve our day-to-day life. I'm honored to have him. We are all honored to have him deliver this inaugural lecture at the Keynote's Distinguished Lecture Series. Eric, welcome.
Thank you very much. Well, if I ever need a campaign director for political office, I know where to look. So I thought I'd go back a bit to why I'm so excited about AI in the open world. It all started with my reading as an undergraduate of Herb Simon's writings about how people and AI artifacts are relatively simple systems immersed in large, complex environments, and therefore we must contend with inescapable uncertainties and incompleteness. And this raised lots of questions for me that I took into my graduate work about what were technical paths forward in this world. Going from a lab environment into the open world, what would that take in the future? In building medical systems that work just fine in the lab, what happened in the hospital and in the doctor's office? And in starting to field technologies and watching them work with people and people work with them, this other interesting challenge or set of challenge problems came to the fore on societal influences and practices and policies. The open world AI problem that was a much broader one than I had been used to. Now, when I took on the presidency of the AAAI, the largest society of AI scientists in the world, I made the theme of my presidency AI in the open world. And as part of that, although most of my talk, and that was a slide from that lecture that I gave, the presidential lecture that presidents give at AAAI, focused mostly on technical issues. It's really exciting questions you have to ask about what does the system, how can you give systems self-knowledge that it doesn't know everything, that it has blind spots when it works in the world and learns to become better, for example, or knows when to ask people for help. I also asked and made a commitment that I would bring together some great computer scientists, probably the first time we assembled AI research scientists, to ask questions about long-term AI futures at the intersection of AI, people, and society. Now, the front page of the New York Times reported this about the meeting that we had after several months of breakout groups and so on. But while these topics were touched upon, the future of machines that might become smarter than us and not let us intervene, we mostly focused on short-term disruptions and possibilities, ethics challenges, and legal challenges and questions. And it was a very rich set of findings. Now, that was February of 2009, and in July of 2009, at Microsoft Research, Jeff Hinton and two graduate students visiting us started looking at neural net systems of the form that Jeff had been looking at all along, but had come into disfavor, given that they didn't work as well as some of the traditional machine learning methods. But we discovered that summer that these methods were simply famished for data all those years. And when we fed them data, all of a sudden we had speech recognition that actually worked. I shouldn't say that that way because Raj Reddy's in the audience, but worked well, to the level of human professional transcriptionists today. Same methods applied to to object recognition and image classification gave us object recognition recently per the data set that's being looked at, human level, as well as reading challenges and other challenges using the same basic set of methods that are really being fed with incredible quantities of data. And beyond simple wedges, we're beginning to assemble pipelines that involve several different kinds of methods, natural language analyses combined with vision to give us automated captioning systems like you see here. And the R&D continues now with recognizing behaviors from video, for example. Now, these interesting new developments have been pressed very quickly into service by the big companies and in academia and by people, the maker community. For example, Skype Translator now translates between languages, speech to speech, in a methodology that just a few years ago had us at the edge of our seats with prototypes that barely worked. And there are widely available tools now that can be used and programmed with by almost anybody that give us the power in software to see faces, recognize gender and emotion, and so on. Now, that said, the reason I'm so excited about this field these days, even beyond some of the foundations of intelligence and the questions there, which I should say, to be honest, most of which remain unanswered, which makes it very exciting. The opportunities to have big influence in the world are huge. So this shows you this readmissions predictor we built several years ago and shipped around the world for Microsoft Research. At the time, we knew that 20% of Medicare reimbursed patients were bouncing back to hospitals within a month, and the estimates for the costs of preventable readmissions were $20 billion in the US alone. Why wouldn't we want to build a system that could learn to predict which patients at discharge time are going to bounce back to give them special care, monitoring, and packages that would keep them healthier? This brings up this issue about ethics. I believe we have an ethical imperative to apply AI to the best that we can, to save lives and to raise the quality of life where we can. Several years ago, just a few years ago, the British Medical Journal estimated, and this confirmed other studies, that the third most common cause of death in the United States is preventable error in hospitals, right after heart disease and cancer. It's like a city the size of Oakland quietly disappearing every year, or Miami, without any front-page news about it. Powerful. So you ask the question, could AI systems augment or extend human intelligence to be like the safety net under the bridge workers, catching errors when they could happen? Now, here's an example of work like that, just to give you a sense before we head into the rough edges of AI. I thought we should start by talking about the upside. This is a model that we built working with, this is Mohsen Bayati and Mark Braverman, two postdocs at Microsoft, and Jason Gatewood, an emergency room physician at a large urban hospital, using 20 years of data. And here's the nature of the training set. For an emergency room department, look at all patients that were discharged and came back within 48 hours to the hospital, within 2 days, were admitted to the hospital with a significant problem as an inpatient, and the primary diagnosis was nowhere on the chart when they were discharged from the emergency room. I would call that an expert human surprise. Something that would surprise most, the expert physician. Something was hiding in the cognitive shadows, for example, of the expert. So when this model runs, it's not replicating what the human knows. It's thinking about what the human doesn't know. What's at the frontier of an expert's knowledge? And when it says, hey, before you let this patient go, this might surprise you. Do you want to see what I'm thinking? A physician might listen carefully. And this work has led to richer work right now. This is with a student, Dae Lee, on a problem called failure to rescue in hospitals. That's a really scary phrase, which means death happened in the hospital after a treatable complication set in, which then led to a cascade, typically an organ system cascade, onto death. Now, these two examples are examples, we're talking about AI designs for complementarity, where we reason explicitly about the blind spots and biases and gaps that people have in their cognition, and think about explicitly, how does machine intellect work with people, work with cognitive psychology, machine learning, and planning to extend our abilities, designing for complementarity. Many AI advances will be applied in this way and make the world better for it. Now, that said, just in if you think about it, just in 3 weeks or so, or 4 weeks, these are actual headlines talking about the rough edges that we're facing and critical problems with advances in this field. So here we have, on one hand, the incredible promise, which is energizing and exciting, but we have to get this other side right and do our best with it. It's critical. So the way I like to abstract some of these problems in my mind are in terms of capabilities. Can we reason about and work with the blind spots and biases in our algorithms? They'll probably always be there. How can we work with them and minimize their impact and their existence? Values. What are the utilities, the values represented in reasoning systems when they do cost-benefit analyses? And with the word agency, in the decision analysis field, we often say for a decision, who's the principal agent of that decision? Which means whose resources and life is at stake? Who is making the decision? A doctor might be helping a patient, but the patient is the principal agent. And then misuse. This is a very, very rich and intriguing area, and this is going to require attention. Human rights possibility violations, legal, ethical, and privacy challenges, physical and emotional harms, exclusion from consequential services, manipulation of attention through capture, engagement, and persuasion. One thing we don't think about a lot, which actually I was happy to hear came up this morning in the first session, is that, and I asked myself, why early on in my career didn't I think about the rich, deep societal challenges and rough edges? And it was because we were building one-off systems. Maybe we could sell a few at a startup. We could talk to the people who were crazy enough to buy these crazy systems and tell them how to use it and fill them in on the downsides and upsides. But now, this is often unstated. We're in a world, because of how much the world changed, because of the web and the connectivity it brought, of ease of replicating, reusing anything that we build at internet scale, which means that nuances in a single solution, we'll call a single solution Facebook. It's a single app, have wide and deep societal influences. So in the back of my mind, I'm always thinking this when I think about AI, right? It's like in the back of my mind. It means like we build something and it could have big effects worldwide. That said, let me just walk through some of these issues and how I think about them, and maybe we'll do some Q&A on this as well. On capabilities and trust, Lao Tzu was said to have said the translation, knowing that you do not know is the best. And the translation goes, not knowing that you do not know is an illness. Can we give our systems the ability to know and not know? So, at the risk of sounding like Donald Rumsfeld, there are now systems that are making life and death decisions, and you're seeing recent deaths about the physical world based on perceptual streams. So this is the view I have in my Tesla. I couldn't resist buying one of these when it came out, given the fact that it was going to do it self-driving someday, in quotes, from the salesperson. And indeed, software came down and it started doing automated driving with the autopilot feature. So when I'm driving along, and you might hear on autopilot, you see a little view of the car and what the car is seeing, the sensors are seeing. And at some point in time, the car might lose confidence. And what you see, you hear an alarm will sound, and you get a message like this: auto steer is no longer steering, model less competently, take over. And the car throws back control to you. No matter what you're doing, you grab the wheel, you know? And at least, this is called a known unknown, because we trust that the car has a well-calibrated model of confidence, and when it doesn't know something. Now think about the challenge of designing a car to be self-driving. Do the people at the Tesla factory or at Ford or at Toyota really have the ability to go through all possibilities? This one got me one night, late night, zooming along on the highway. I saw cones in the distance while on autopilot, and I wondered, does the Tesla know about cones that, you know, that sweep across the road and close a lane? I waited and waited, and then I said, hands on the wheel, it's not going to know, it's going to hit him head on. But I had no knowledge about what the car didn't know. This is another example. People know Jeanette Wing and XD Wang. They're two alums from CMU. They were driving with me to an exec retreat in autopilot when we encountered this scene. And it wasn't clear to me that the Tesla designers had this in mind. So we took the system out of autopilot. So this is the challenge of unknown unknowns. And it's a real challenge. We call these blind spots. Now, in the technical work, we can actually even use deep neural nets to focus them on the problem of learning to predict confidence and how a base level system will work. And then there's new work on my team and other teams coming about, which are ways to triage human engineering attention to find blind spots, to identify unknown unknowns in the open world. This is early research, but it's critical, and even in reinforcement learning. And in this paper here, how do you discover blind spots in a system that learned its whole life how to live and do its thing in a simulator, now put in the real world? Where should it be scared about? Where should it be a little bit nervous or anxious? But beyond the technology, and I think that it's very good research, and I'm sure we'll see great research coming out of the CMU departments, which have been leading, I can now say, the #1 department in AI in the country, per US News and World Report. Round of applause. I would actually say, look, US News and World News apart, I'd say well-deserved. But beyond technology, there's the idea of practices and designs. So why not, what is the policy at which we defer the fielding of technology? We say it's not ready. Maybe for trials, but it's not ready to be used by the large populations. Or do we need to have phased trials like the FDA? Clinical trial, phase 1, phase 2, and post-marketing surveillance, required study, and standards of reporting during these times so we know what's going on. Let's say we want to field technology. How do we disclose the nature of the behavior, the risks, and the failure modes? And there's a whole field outside of AI, and in many cases outside of computer science, called fail-safe design, like air brakes on trains, invented in Pittsburgh, actually, that are used worldwide. One of the first examples of fail-safe designs where if anything goes wrong, the system stops. We can fold designs, but with blind spots that we can't get rid of, potentially with new kinds of engineering practices. This area of bias and fairness is getting quite a bit of attention, and it's an important one. The article by Julie Angwin and co-authors focused on this idea that or the reality that there was a system called Compass being used throughout the country to help judges make decisions on bail and on holding a person charged with a crime versus letting them go before their court date, thinking about whether they'd commit a violent crime in the meantime. And the article about the challenges that were discovered, some of the challenges, and it's still being investigated because it's not all straightforward, that here are 2 cases that, sort of were analyzed by the data and some of the risk reports that came up. Now, it's not just the high-profile cases that have these problems. It's prolific. So at Microsoft, Anna Howard a roboticist who visited with me for a year and a half ago, and we looked at some of Microsoft's cognitive services. And this is a cognitive service, as we call them. These are services available on the Azure web, available for use in programming for emotion detection. And we discovered that the emotion classifier, it's not as charged as race, but the emotion classifier had certain failure modes for children. And we went and looked and studied the data set, and we had to find it and who did the data set. And oh yes, it didn't have a lot of children in it. And therefore it was biased in that the performance didn't work as well in some areas. And this has led to other studies like this have led to large-scale efforts inside Microsoft, and more on that in a few minutes, to come up with ways to detect and address biases in our services. On values and agency, let me just show you a curve here. This curve up on the screen here is the typical kind of performance curve that computer scientists look at when they build a pattern recognizer or a machine learned classifier from data. And they typically hold out a little bit of data, usually the most recent data, let's say in a medical case, because the most recent data, it looks like the data you'll see in the world. So they hold that out from the training, and they say, we're going to test our system with this holdout set that the learning algorithm has not seen before. And then you generate one of these curves. And what you see on there is a true positive and a false positive rate. So it tells us, for example, and this is actually one of the receiver operator characteristic curves, as they're called, one of the curves from the readmissions prediction work we've done, one of the early curves in our research from about 15 years of medical data of readmissions to a hospital within 30 days. So the idea was we want to predict when patients will return to the hospital within a month. It's actually tracked by Medicare. It's a penalizable quality measure. And it says here that if you operate at this threshold here, we can tell, the classifier will tell you, if it says patient's going to come back, 3/4 of the time it'll be correct. But the false positive rate will be 25%. They won't come back. And you can imagine moving this threshold around and having what are called different operating characteristics or operating ranges for this classifier. Well, it turns out if you think about what does it mean for a true positive and a false positive, it means something very different for your spam filter, right, than for a patient, and for a cardiac patient, for example. This gets at the idea of costs and benefits. And depending on where I pick that threshold, really affects the performance of the system in a way that affects the end user's costs and benefits that they receive. And this includes significant health implications. Now, looking at this more broadly, the golden, go back here, most machine learning research takes data sets and gives you probability distributions about what you care about, like a prediction. What disease does the patient have? What's the wind flow going to be over a city in the United States from wind sensors? What emotion does somebody have on their face right now? And we need to do more of the full decision analysis because decision making based on the predictive model is where the rubber meets the road. And so I call this the kind of like the golden data to predictions to decisions pipeline. And this is where we really get into value. And it's not just automation, it's for recommendation engines as well, to a young doctor, for example, looking at the output of one of these systems. Now, think about the decision model. The decision model takes in a set of probabilities, and based on a cost-benefit consideration, outputs the ideal action to take. And that depends on the details in that decision model, which capture the value or the utility structure in the person being affected. That's the intention, the principal agent of a decision. Now, we discovered when we shipped our readmission system that a large hospital system in the Midwest of the United States was playing with thresholds. And they said, when the Microsoft score, it's actually a probability, but they called it a Microsoft score, is greater than 25, they will initiate a special package for a patient, which costs quite a bit of money, but they'll initiate it, they'll take that charge, and it turns out by doing that, they saved $1.4 million per year in the hospital. we sat down and did a rich decision analysis with many costs and benefits and wrote this up and so on, and showed that the actual details were quite nuanced and they really depended on careful modeling of the utility function. So you can't just ship a classifier and have it be used in the world and expect it to do the right thing for everybody, because health, different attributes of what you care about in a health outcome go into the utility structure here. So you have to ask, in any AI system, whose utility function, what cost-benefit analysis, who assessed it, who refined it, who inspected it, who do we reveal it to, disclose it to? Now, on misuses, as we all know, it's quite possible to use these technologies to empower and amplify the tyranny of leaders who don't have the best in mind for their populace. Freedom of association, freedom of expression, new kinds of surveillance and policing. But also, a misuse can include the risk of death or serious injury in a system that's just failing too much to be shipped, or a system that's unfair and it's denying consequential services and resources to people, or a system that's manipulating the attention, beliefs, voting patterns, and cognition of people. Let me talk about that last notion right now, because it's been on my mind quite a bit lately. And as I mentioned in a few minutes, we have a working group at Microsoft right now looking at this very carefully. The idea of using the best minds coming out of our grad school departments in machine learning, going off to work at companies that are harnessing their talents to optimize what your attention is focused on. How much time are you spending on an application? So if you look at this pie chart here of all the things you attend to during the day, we know now that large-scale data analysis and planning and personalized policies are being used to maximize your attention and time on applications. And this is in accordance with optimizing the dollars back to the people writing those algorithms. Now, back to Herb Simon again. Herb Simon talked about a poverty of human attention coming in a world full of information and distraction. It's an important concept to think about what this is doing to our daily lives. I like to use a less polite phrase that these are adversarial attacks on human attention for someone else's gain, whether it be shareholders or owners of a company. So thinking forward on where we're going in the world with this and what our kids will be immersed in and our grandkids, we have to think deeply about preferences on time well spent, long-term preferences on what we want to be doing with our time, and thinking deeply about policies, disclosure. Should I be told that there's an algorithm focused on my mind that maximizes the time of engagement I will spend in this application? Controls and education. Perhaps as interesting and intriguing and concerning is AI manipulation. We have people, even here at CMU, study marketing. It's a great concept and topic. And people have long studied propaganda. They're experts at that. There are different words and there are different intentions. But the idea of turning away from back-of-the-envelope theories and sketches to large-scale data-centric manipulation is concerning. So work by Seymour and Tully a couple of years ago that I was talking about a few years ago when this first came up, took a large number of Twitter feeds, including geotagged Twitter feeds. Where is somebody right now? What are they doing? And so on. What have they tweeted about in the past? And showed how you can build very personalized tweets. In this case, tweets being written by a neural network that would have a maximal probability of a user clicking on a link. And even created toolkits you can now download and use to build your own robo-tweeter. We've heard a lot about Cambridge Analytica recently and Facebook data. Well, a few years ago, when I made this slide, before we had such noteworthy news, I was talking about the concerns in a nice academic paper by Kaczynski et al. That showed from just Facebook data, from a little bit of training data, I'm not sure what little bit was, by the way, but here are the inferences that are being made from just a Facebook scan of your Facebook feed. Are you single or in a relationship? Were your parents together at 21? Christianity versus Islam. Gay, lesbian, or straight. Uses drugs and alcohol. Satisfied with life. That's interesting. Emotional stability. Age, gender, and so on. So there's clearly going to be need for some reflection and guidance in all those areas that I mentioned today, the capabilities and how to handle blind spots and biases, the values and the idea of principal agency, and this whole area of the potential harms that might come with uses of these systems to human rights and related areas. So I see that there's a continuing a need for, I would say, continuing processes like the endowment that came to CMU for this program, for study and proactivity. We need to fund these kinds of programs and centers. There are roles for industry, for the academy, for civil society, and government. 5 years ago or so, my wife and I came up with a crazy idea, and this was at the kind of the 5-year point after the Asilomar study, the AAAI study. And we looked at the report and we said so many interesting questions came up and so many were so prescient in terms of what was being said about what we needed to care about. 2 or 3 things were like just dead on. Maybe we were lucky, but they were very interesting. And if we had followed some of the guidance, we would have been further ahead. And we thought, let's do another study, plus 5 years. But it really was clear to me this would have to happen plus 5 years several times. And so we thought, why don't we endow Stanford with a study? And John Hennessy at the time thought this was a great idea, even though the development office thought we were crazy. But every 5 years forever, have a standing committee that works with a study committee that does a study that's aimed at proactive advice for governments, academia, the public at large, civil society, on problems coming to the fore. And the first report was published about 1.5 years ago. What about corporate responsibility? That was kind of philanthropic and academic. I've been doing a lot of reading lately of Peter Drucker's work. Who knows who Peter Drucker was in this room? All these Heinz people are here and others. So Peter Drucker, I think, defines some of like 20th century deep thinking about business practices. I think he came up with the whole idea of an MBA being even a field. He said that profit is not the primary goal, only an essential condition for sustainability, and that a company's primary responsibility is to serve its customers. Here's a quote: "Leaders in every single institution and in every sector, not just business, are responsible also for the community as a whole." We're not in it just to maximize shareholder value. That said, I've been impressed. I don't want to be doing an advertisement for Microsoft here, but I've been impressed with the responsiveness of the company to concerns about the long-term futures and even short-term needs and rough edges with AI systems. We set up about 2 years ago the Ethereum Committee. It stands loosely for AI and Ethics in Engineering and Research. There are 7 working groups. It's been an intensive effort, touching on every issue that I mentioned today. And I should say that, I'm happy to say that this committee has teeth. So when it came, so someone mentioned humanitarian issues, and some questions have come up about what could a company do when it comes to technologies being used that put it at risk for human rights commitments. And I should say that the Ether Committee has made recommendations which have gone all the way up to the senior leadership, and significant sales have been cut off. And in other sales, very explicit limitations were written down in the terms of usage, including may not use data-driven pattern recognition for use in face recognition or predictions of this type. So the Ethics Committee has working groups, and we refer to the guiding principles on business and human rights. And Microsoft has its own global human rights statement we take very seriously, and that we see going right up to the top of the company. If we say we see a challenge, we point at this document and we say, this is a risk to our commitment. Selling this technology to this customer. Moving to the community, the larger community, I want to talk a little bit about the before I finish up here, the partnership on AI, which was a consortium started about 3 years ago. It started with leadership by the research leads at the research laboratories at Amazon, Google, DeepMind, Microsoft, Facebook, and IBM. We all know each other as colleagues. And when it came to discussions at conferences, we said, I wonder if we can drag our companies, whether they're kicking and screaming or they're happy with all this, into a consortium, to a nonprofit focused on best practices across a set of interesting questions and challenge areas at the intersection of AI, people, and society, including safety-critical systems, fairness, accountable, and transparent algorithms, human-AI collaboration, AI labor in the economy, deeper social and societal influences, and we're talking about some of the issues I talked about with persuasion and manipulation, and so on. And it's led by a balanced board, including folks representing the ACLU, nonprofit AI research, foundations, economists, privacy experts, and AI scientists. Recently, we brought on Tara Lyons to be the executive director, and she's doing a great job getting this operation up into the air. So moving ahead, I see the direction we need to pursue includes ongoing research on the principles, the foundations. They're so exciting, and we need to better understand human intelligence and its computational variance. We need to work to apply anything that we know and have learned to key societal challenge problems. We need to continue to identify and address costs and influences of the technologies and ethical and human rights challenges. And I say that we need to collaborate widely on the technologies and their influence on society in a multi-party stakeholder approach, including economists, public policy people, psychologists, and so on. And let me just end back to Herb Simon again. And I want to basically set the bar lower for us. I think we're facing some very tough problems, and I want to just talk about satisficing, one of Herb's words. And he said that professional responsibility is not to discover the laws of the universe, but to act responsibly in the world by transforming existing situations into more preferred ones. I'll stop there. Thanks.
Have seats. Thank you so much. Thank you so much. It was really a wonderful talk. And I think fit all of the themes. I think you hit every single one of the session themes over the course of the talk.
I tried.
Thank you so much. I wanted to start by asking about actually a theme that has been a part of your research since the beginning, which is this idea that we need our AI to fit nicely with human cognitive features, human cognitive biases. And so in particular, there are now many calls for AI to be more transparent or explainable. Could you say a bit about what you think is needed for AI beyond just accuracy or simple performance measures like that?
So there are many applications of AI, including many applications that you might say are running under the hood. So Windows 10, for example, has machine learning running all the time in a private way under the hood, guessing what you'll do next. And then prefetching and preloading, so everything's faster magically, if it's done well, and I think it is. It's been running for a number of years in different versions since Windows 7. We don't ask for transparency on that unless you have a special request as to what's going on exactly. We want it to be very efficient. In human-facing technologies like dialogue systems, we might want to have other features that, more human-like, comfortable with humans. Humans are not weirded out by the technology. Assurances of privacy. When it comes to transparency, it's an interesting question. I think that it's going to vary depending on usage. I see someday us wanting to make sure that some independent party that we trust as a proxy has certified, for example, the data sets that were used, the processes in place, that systems are fair and unbiased, person-protected variables, for example, that the best algorithms were used, an underwriter's laboratory or an FDA. Somebody's looking at this as best practice and relieves me of the need to go inspecting and wanting to know all about what's going on. In other cases, I think we need to sort of think through a system working with an expert, how to best explain inferences, how to do sensitivity analysis, do something called counterfactuals. What would have happened if this patient didn't have that black mole but still had this other dermatologic feature? Do visualizations. We found in that work that I showed you that showing this 2D visualization of how cost and benefit interacted under uncertainty for a population was very useful in understanding policy at a hospital. I think we can't look at AI as one thing. I've got a high-level comment here. It's an interesting phrase. I think artificial is actually unfortunate. I wish it was called computational intelligence. Artificial scares people, I think, the word. But it refers to a large set of related disciplines arrayed on understanding the kinds of things that people can do with ease from a computational lens. And there's many things. It's an empty canvas with lots of paint. And we can do many things with it. And each of those points in that space will have different requirements in terms of how best to adapt to human beings, how best to extend or constrain the system in a variety in ways that make it more usable, acceptable for human interaction.
Well, this idea that the AI, we have to think not just about the AI, but what it's for. So it's AI for a purpose, for a goal, whether that's defined in a loss function or some other way. I guess that raises a question because, of course, diverse people can have diverse goals that might even come into conflict with one another. So is that something that you think falls to the developer? Does that fall to the user to figure out what the goals are? Should we allow the AI to try and learn what my goals are? Or is that a fraught project?
Well, let's just talk about what's shipping today. We're talking about relatively fixed technologies that recognize patterns and do very relatively simple things. So when we build those systems, we want to annotate them very carefully, including how we test performance, which is like this system was built from this kind of data. Its intended purpose was to detect age or gender or the emotional status from someone's facial features. This system performs this well. How do we know that? Here is the representative test set we used to even understand this performance, which captures an intended purpose. Now, you can imagine weaving that inference into another system that's using it in some way that still understands the intended purpose. Now, in the future, in a future world where we're training systems in the wild to learn general things about life, which doesn't exist now, you can imagine all sorts of interesting questions coming to the fore about does the system that was trained at the factory to this level and then trained at my home with more data to personalize it, does it perform well when my husband or wife uses the system or when my kid interacts with it? And I think these are big research questions that we don't have great answers for right now.
But I think a theme that ran through a lot of what you were just saying is about the importance of a certain kind of technical literacy, technological literacy, that is perhaps lacking in a lot of the public and a lot of even policy and decision makers, in terms of being able to understand the role of training data, or how to go from it was trained for this purpose, therefore it probably shouldn't be used for this other one.
Right.
So
it's a good question to ask ourselves. It's probably going to be hard to assume we can train people to understand the details of what goes on with these systems. But you would hope, for example, someday, when it comes to what an automated car will do in one of these famous settings or a nuanced situation, that rather than being concerned with what the auto manufacturer had to say about this, the car is not drivable in automated mode until there is clear signals that the end user watched material to learn about what these trade-offs are, and then went ahead, after even taking an exam or test, and assessed preferences. So it's the driver's knowledge in the system when that car moves forward, or the driver's preferences about behavior. And you can imagine modularizing operations in a certain way where, yes, I feel comfortable that I could actually explain to an end user, even without much computer science education, what's going to happen in the setting visually, and help visualize and with sets of controls get at end user assessments directly. So again, it's up to computer scientists and engineers and manufacturers and salespeople to make sure that these systems, these more sophisticated systems than we sold in the past, are well understood by the end user. And by the way, this also includes maintenance. We never really thought about what it takes to maintain a system in a dynamic world once you ship it. When we shipped, I'll say this out, I'll let it know this. When we shipped that medical system, that readmission system, years ago, it worked really well. We trained it and tested it in many hospitals. What it did was it trained and tested locally, because we found that the data set from one hospital didn't do well to generalize to another hospital. It was fine. Right before we shipped it, I said, wait a minute, maintenance. We didn't even think about these issues in those days. It's a standalone package that runs with data locally. I said, can you have that system, whenever it retrains anywhere in the world, send email to me with that curve? But nowadays at Microsoft, we say, what are the terms of reference and the terms of usage, including required maintenance and check-ins by end users, so they understand that the world moves around and it's dynamic, and you have to really keep maintaining these systems to make sure they perform well.
Well, and of course, when we think about local learning, there's a rather notorious case where local learning went poorly, and that was the chatbot Tay. So how do we balance ensuring that the local learning occurs in an unsupervised way? There isn't a human there necessarily looking over the shoulder anymore, but that it learns the right for achieving the goal that the developer and the end user had in mind.
Yeah, I was going to comment on Tay.
Sorry.
In that it's a great example of things going awry. But it wasn't a very deep AI system at all, and it was attacked by malevolent attackers. But that doesn't mean it's not a great example to think deeply about what might happen in the future. You can imagine giving systems the ability to monitor their performance. There's lots of chatter about what does it mean to add a layer of reflection in systems where the meta-level reasoner is simpler, and it looks out for certain problems. So it's not very complicated, and it's there as kind of a sentry to make sure that what's going on at the base level, the complicated system trying to learn about the world, is not getting off the rails, and reports out and actually monitors what's happening. So you can imagine as we build more reliable software, we build into them, besides having people maintain them and oversee them in certain situations, give them the ability to have a layer of an overview or a meta view of what's going on at the base level.
So they could start to recognize that there's some unknown out there. They may not,
right.
Of course, be able to solve that.
And in fact, there's some really fabulous work by Tom Dietrich over at Oregon State right now on systems that actually learn when there's another class out there. in this case he did it for biology, but that the system didn't know about. And there are certain signatures that will show up if there's something you just don't know in the world that's doing its thing, and the blind spot has a signature. And so you can imagine that kind of method as well. I do think that the nature and the sophistication of our technologies will be morphing over time, and that rather than saying we have solved this problem, we need to have these continuing studies, like the 100-year study, like the ethics and AI program we have here now, like the new Block program and so on, Block Center here. I think these are all going to be required over time. These challenges and opportunities, I would say, aren't going to go away, and we'll have solutions that will cascade and be layered, and we'll build on them. But I think we need to stay on it, basically, because the advances can change our best controls, meta-reasoning understandings, debiasing techniques as we go.
And of course, those same things then interact back on the human biases. So you think about things like the people's loss of awareness when they go on autopilot. So the Tesla takes over for you, and you know to look at the orange cones and be ready to take over. But we also know from aviation studies that it's very hard for people to take over, as I'm sure you've also had that experience.
Yeah, the whole issue of and the importance of social and cognitive psychology in understanding the human-AI relationship and in human-AI collaboration and interaction more generally is deep and broad. It's great that CMU has fabulous expertise in both human-computer interaction and AI, and now these ideas are coming together in a variety of places, but here as well. And just even thinking about, I have some really great pieces of video that show prototype robotic surgeons working with human surgeons hand in hand very quickly. And you can imagine that if you had a robotic surgeon working with a human surgeon, you see literally 4 hands or 3 hands in a scene, and the signaling going on is who's doing what, whose turn is it? The idea of a mix of initiatives, a back and forth. How does that work? How do we do it in a fluid manner? We're sitting here chatting in a fluid manner. You're doing predictions about when I'm going to end a sentence and so on, when to start, who's making contributions. There's a whole rich literature in psychology for mutual grounding and conversation that we think is going to be important for any human-AI interaction when it comes to interactive AI and fluid collaboration.
Well, and also making sure then that the AIs are able to, as it were, augment the humans rather than simply replace them, which I think connects with a lot of the workforce issues that get raised about the development of AI technologies.
Right.
Is how can we have the AI help the human rather than simply replace the human, thereby leaving them out of the workforce?
Well, I personally don't think that we ever want to constrain the advance of technology to say, we don't build systems that replace people. People used to drive cars around and adjust the dwell angle of their sparks on their steering column. I don't know who remembers that, but and now we have automatic dwell advance for those of you car people out there. So some jobs, or tasks we think will be automated, and it'll shift the nature of the human task. We hear about who's the radiologist that said I'm going to go away. So you're awesome. As you know, radiology is not necessarily about only recognizing patterns and features on a film. It's about helping the ordering physician with the plan, the rule out, the strategy, what tests will work the best. It just will potentially shift the nature of the job and what's learned to be an expert radiologist. And the solution to a certain subtask in radiology, plus the human, might create a very different, more powerful position in the future.
Right, finding ways for the human and machine to team together to advance far beyond what either could do by itself.
But there certainly will be automation of the form that ameliorates the need to have a human being on staff or on hand. Now, one thing we were discussing actually, this brings up earlier today at lunch, was whether the rise of automation in the world, I'll just maybe throw this out to the audience, whether the rise of automation will will help to pressure the economies into valuing human touch and human contact more, the rise of a caring economy. As some of the things we rely on people now become automated, if there really is more wealth created by this automation, won't we actually want to value human experience, human beings more someday? And teachers and mentors and elder care providers are the top paid human beings because they do the job the best.
Well, I think educators absolutely should be the top paid. It's a wonderful idea. And I think on that wonderful question,
All right.
thank you so much,
Okay.
Eric.
Thank you.